Hey, g'day, it's Prezzo. Thanks for stopping by. As you can see, I've got the Douglas shaper in the middle of the workshop today, and this is now in a condition where it's ready to cut metal. Now, it has actually been running for the last couple of months, but I didn't actually use it to cut any material because there were a lot of sort of tweaks and adjustments. I had to make some parts to make it cut more accurately, and I've got all of that done in the last week or so. And I wanted to show you today two castings that I need to make for this machine. Now there will be handles which didn't come with the machine when I bought it, and there'll be one made in brass, one in aluminium. Now I didn't do a separate series of videos on the refurbishment or the restoration of this machine because I was busy working on Thread Express and I wanted to get that finished and out the door, and now that that's done I've been able to turn my attention back to this machine here. So I'm going to give you a close-up look at some of the work that I've done on it. I won't dwell too long on it, and then we're going to have a look at the casting. So let's have a closer look. One of the major upgrades I did on the machine was to fit this 1 kilowatt 3-phase motor. When I bought the machine it had a single phase and I think it was only 3/4 of a horsepower, and it was okay, but I think just increasing the power of the motor is probably a good thing. I've also got a Bosch Rexroth VFD down below there. Now I love these VFDs. I've actually got 3 of them here in the workshop. There's one on my metal lathe, I've got one on a wood bandsaw next door, and this one. And I like them because the manuals are written in plain English. They're very easy to read and understand. They're very quick to boot up, very reliable, and also the inputs on these are programmable. So that meant that I could fit a remote start-stop switch and also the variable speed, and I can also program a button that gives me a jog function, which is really important when you're setting up a shaper. So I'll show you that in a moment. But the one thing I need to do here is make a screen for the top of the VFD to stop any chips getting down inside the electronic guts of the VFD there, which could possibly cause a short. So I'm going to 3D print a little cover with some very fine steel gauze or steel mesh in that, just to prevent chips getting down inside. This is the start-stop box that I built into the machine here. This can be rotated and locked in any position, so depending on where you're standing and where you're operating the machine from, you can always see the controls and get at them. Now when I bought the machine, it didn't have any start-stop switch on it at all. You just plugged it in at the wall and you turned it on at the power point and the machine would start, which is not very satisfactory. But with this unit here, the start switch latches on, and this is the jog button here. If I press that, you'll see that the RAM moves very, very slowly, and that means that you can check the start, stop at the stroke. There's less chance you're going to crash it into something, and it just stops as soon as you let go of the button. And here's our variable speed here. Okay, let's have a look at some other features on the machine that I've upgraded. When I refurbished this machine, I fitted these little brass oilers with the caps on both sides of the RAM here. Originally this just had a drilled hole with a countersink, and you just filled up the countersink, but the oil would potentially run through very quickly. At least with these you can fill the entire cavity of that little oiler there. That's going to give you constant lubrication while you're using the machine. Now on this side here there are 2 of them, one on either end, and on the other side I had a problem, so let's have a look at that. Here's the same 2 oilers on the other side. This front one's fine. When I fitted this back one here, I didn't actually have this pointer attached on the RAM, and this is the stroke indicator. And when I fitted it, I suddenly realized that it's going to crash into this back oiler here. Now rather than change the indicator, what I'm going to do is to make a new brass plate with the stroke length on it, and I'll shift this oiler just a bit behind this brass plate here. It'll still work, and yes, it's not symmetrical, but it's better than having this crash into the oiler. So this has a stroke of 10.5 inches, and of course the graduations on the scale here are actually 1/2 inch for each inch of stroke, and when the RAM is in the middle of the stroke it sits at 0 just here, and then if you increase the stroke you can take the indicator all the way down to this end here, which is 10.5 inches. But I've already drawn up the artwork for this, and I'll chemically etch a new brass plate and fit that, and it won't have that hole for the oiler, and I'll put a plug in the existing hole, drill a new one just here. To change the stroke on the Douglas you need to remove this cast iron door, and inside you see a hex nut. you can slacken off that nut there and you can slide the bronze die nut up and down in the rocker arm to set the length of the stroke. And when I got the machine, the existing bronze die nut was really badly worn, and I did actually make a new one. This is made of phosphor bronze, and it's now a really good snug fit. But what I found out was that the slot in the rocker arm was actually worn wider in the middle than it was at either end. So after I made the new bronze die nut and fitted it, it wouldn't move much more than like an inch or so either side of centre. So I had to scrape the sides of the rocker arm slot there in order to get the bronze die nut to move full length. But that's fixed up a lot of the noises that were coming from the machine originally. I also fitted new bronze bushers to both ends of the rocker arm and the top and bottom links. So again, that got rid of a lot of the slop and the play in the mechanical system, and it's much smoother and much quieter now. So that's all good. Also laser etched a new plate, a new maker plate for this one here. This is the original, it's fine. This one was really badly faded and worn and dented, so I did laser etch a new one. Another really necessary upgrade as far as I was concerned was to fit a new lead screw. It's metric and 2mm pitch. I also fitted a new bronze lead screw nut and a new micrometer collar. And this is graduated in 0.02 of a millimeter divisions, and it's got a friction clutch on it so you can set it to 0 and then advance the tool by whatever setting that you want. So to me, this is something I'm really familiar with. I can use inches, and it doesn't matter to me really, but this is the most familiar and also the most idiot-proof as far as I'm concerned. So that's that's lovely having that. This is the original vise that came with this machine. Now it is the original Douglas vise, but when I got it, it was in a pretty poor state. The vise jaws were really badly worn and damaged. Somebody had run the tool into the fixed jaw at the back here, and the whole thing just needed cleaning up, and everything's been repainted on the whole machine. And I found this old high-speed steel in a box full of bits that somebody gave me, and I don't know, it looks like a shaper tool, so I've just given that a clean up and reground it, make it sharp. Seems to be cutting okay. I've also made a shear tool. Now this is one that I saw done on Dean Crawford's channel, the Air Cave Shop, and he reached out to Michelle at Rustinox, who's the guru as far as shapers go, and he sort of demonstrated how you would grind that. And Michelle, I hope that's correct, but I haven't had a chance to try it. What I'll need to do is to make a sort of like a carrier to go in the tool post here, because this has got quite a large opening for much bigger diameter or bigger square tools. But I'll make a block similar to this one so I can fit that smaller high-speed steel stock in there. Okay, I guess you want to see it run, so let's do a bit of cutting. Now if it looks like the vise is moving, it's not. It's actually the whole machine moving on its caster base. I have actually got some jacks that I can use to jack it up off the floor. I haven't done that, but yeah, that's what's causing that relative motion in the camera frame. So as you can see, it's sort of cutting really nicely. It's not really a challenging cut for this machine. I could probably go a lot deeper and take a bigger step over on the cut, but I'm still getting used to it. I just need to learn what the capabilities are, but it's way better than what it was when I got it. There's none of that sort of clattery noise that you get when you've got slop and clearance in a lot of the parts. So yeah, I'm very happy with it. See if we can go a little bit deeper. Okay, I think you get the idea. Like I say, I still need to use the machine quite a lot to get used to it, but so far it seems to be doing what it's meant to do. So I guess now we need to get on and actually talk about what today's video is really about. Okay, so take a look at that. Now this is the original cast aluminium handle. It's got a square socket that fits over the two square ends on these feed shafts here, but it's really badly worn and flogged out. And these have a tendency to walk off the end of the shaft when it's left on there, and you don't really want it falling on your foot. So what I'm thinking is I want to cast a new one of these with the square hole cast into it, and that will mean making a square core to go in the casting. Now I did think about machining one of these from solid stock, but you need a lot of stock to do that, and you still got the issue of how do you get the square hole in there. So that would mean either broaching or shaping it, and I know I've got a shaper now, but just for the fun of it I thought it would be better to try and cast this with the square hole already in it. Okay, now there is another one I need to make, and we'll have a look at where that goes. So up here on the top of the machine there's another one. Now this one doesn't fit, alright, so can't use that. And this one is used to lock the ram in position after you've set the stroke position, and this one here is used to set the tool slide over to whatever angle you want to use. Now you could just use an adjustable spanner, but again I think it'd be fun to try and make a proper cast handle to go on these two square ends here. Now aluminium I think is probably not durable enough for doing this, so we're going to have a go at making one out of brass. Now it turns out that this vice handle that came with the Douglas vice is actually cast in brass. So it's quite heavy, and initially I thought, oh, why would they use brass? Surely cast iron would be better, but for whatever reason that's what it is, and it seems to work fine. So I'll make a cast brass handle to go on these two squares here. Now, these are the two patterns that I'll be using for the casting. So this one here is for the aluminium handle, this one for the brass handle, and these are 3D printed split patterns in PETG filament, and I just do them the same way every time. They're lightly sanded all over, then they're painted with a spray putty, like an automotive spray putty, sanded back smooth, and then I've had a coat of red acrylic lacquer over the top of that. Now because of the humid weather that we've had, the paint is dried with that sort of a white blush to it, but it's not going to be a problem for the castings that we're doing. Now these projections on either end here are the core prints, and that's where the sand and epoxy core will go when we go to make the casting. Now to make the cores themselves, I've got these 3D printed core boxes. So again, these are split. These little notches are to make it more flexible so you can get the core out more easily, and I've got two of them. And what we need to do now is get these prepared for making the cores. Now because these are 3D printed, you get the layer lines on the inside after the printing is done. So we need to sort of prep these and get them smooth on the inside there. And all I do there is I just get some white woodworking sandpaper. This is 180 grit. Just get a bit of wooden stick there, and then you can sand the inside. Now, you don't need to go to a lot of trouble. Okay, I think that's all that needs. What I'll do next is I'm going to coat the inside of these core boxes with a woodwork finishing wax. Just about any type of wax will do the job. I reckon you could probably use like a baking spray or Vaseline. Yeah, just all you need is something that forms a barrier and stops the sand mix from sticking to the inside of the core box. Now I'm going to use epoxy resin and sand. Now I know you can use sodium silicate, and I have used it before, but just using the epoxy resin and sand means I don't need to keep a cylinder of CO2 gas on hand to cure the cores. The downside is you need to do them and then wait overnight for the epoxy to set. But as far as I'm concerned, that's not a big deal. So this is the wax that I'm using here. I've got another paste wax in there, but I found that this stuff works fine. And it's sort of more of a liquid. So that's done now. We'll get the others completed, and then we'll mix up the sand and the epoxy. So to make our cores, I've just got 12 grams of a clear epoxy resin. This is just one of those craft resins that you can buy. This is a 2-to-1 mix, and all you do is just mix that up. And I've got about 150 grams of clean white sand in this container here. The ratio is around about 8%, but in reality what you do is just keep mixing the epoxy into the sand until it resembles like a green sand, and then you pack it into your core boxes and just let them sit overnight. So I'll go ahead and do that. I'm just going to hold the core boxes together with some masking tape. But you could use zip ties or rubber bands, whatever you like. So I'll just start off with about half of that epoxy. Okay, that's starting to look pretty good. Eventually you just got to get your fingers in there and give it a really good mix up. And yes, wear gloves. Alright, and that's about the consistency that you want. It sort of should press together, shouldn't be too sort of granular. Alright, now we're just going to pack that in there. Okay, that one's done. I'll get the other one done off camera, and then we're going to put a vent down the centre of it. Right, so they're packed and filled now, so I'm just going to get a piece of MIG welding wire and just put a hole down the centre of each one of these. And this just helps to vent any gases that build up when the metal's around this. So you got, super hot metal around this resin and sand, and it's going to generate some smoke and gases, so you want that to escape. Alright, that's it. We're just going to leave them to cure overnight, and then we'll unpack them. Alright, these have cured overnight, so we'll see how we got on. I just sand the ends of the core box. Just remove any excess that was there. So I'll cut this one open. And they do come apart very easily. And you can see that printing in those little notches there makes the core box flexible, and you can open it up fairly easily. So there's that core. So that one's good to go, and these are really strong and durable. I'll get the other one done off camera, and then we'll get the actual moulding done. Alright, forgive me for doing that in time lapse, but I'm sure you've seen sand moulds being made before, and I didn't show the other one. It's essentially the same. So we're at the point now where we need to fit our sand core, and I've lost a little bit of detail on the edge of this mould here. At the end of the day, it doesn't matter that much. You'll get a bit of a flash line on the finished casting, but we can file that off. One of the good things about making metal castings is that usually defects add material to the finished product, and usually in places where you can remove it easily. Now the exception is when sand particles fall off and lodge inside the cavity, and they will make voids in the casting, so you want to avoid that at all costs. And that usually means blowing out the mould really carefully, closing the mould, doing a trial close, lifting it open again and checking to see if any sand particles have dislodged. So now I need to put the core in. This is always the hard part for me. Doesn't help if you've got very shaky hands. So I'm just going to lower this in. And the core is slightly shorter than the core print. So there's a space at either end of the core. And then as the liquid metal fills the mould and heats that core up, any gases and smoke and debris will lodge in those little open spaces at the end. So I need to put the cope on the mould now, and I'll close it, open it again, check for any broken sand, and then we'll go ahead. Now this is the one that's going to be cast in aluminium. Okay, that looks good, so I'll close it up for good, and then we'll go ahead and I'll do the aluminium one first. Alright, how'd we go? Legend or loser? Looks alright. Nice and shiny. Yeah, got a little tiny void there, but the core is still intact. Yeah, I think that one's good. We'll check the brass one. Legend. Yeah, that's good. Alright, so I'm going to knock these cores out. There's a little bit of brass on both ends over the top of the core. That's where that void was. And of course it's got a lot of flashing along here, but that's okay, that'll file off. So let me get these cleaned up and I'll show you up close. I've cleaned all the gates and runners off both the castings now, and you can see this core here. Now this used to be white sand with epoxy in it, and now it's sort of like a chocolate brown charred colour, and it comes out really easily. I'll put this in the tap or under the tap next door. That's why it's all wet. I'll give that a wash out, but that looks good. This is the aluminium one here. So I'll give that another wash out next door, and I'll have a look inside. Now I don't expect these to fit straight onto those square shafts. They're going to need a little bit of filing, but they should be really close. And I'll get all this flashing cleaned up. It's going to make it look a lot better. There they are, after I've given these a really good clean up with files and the belt sander and a Dremel with a drum sander. And that's gotten rid of all of the flash on the joint, the parting line. Now I did get an inclusion just there. That's where something had fallen into the cavity of the mould, and that's where I cut it with the hacksaw while I was cutting off the gate, and yeah, that made me rather cross. But I can fill both of those defects with some JB Weld, and these are going to get powder coated, so you won't even notice it. So here's the brass one. Again, it's all cleaned up. Now I don't expect these to fit, but just for fun, let's go and try them. So this is where the aluminium handle is meant to go. You can see how loose that is. And here's the new replica that we've made. Now, it sort of goes on. It sort of wants to go on there, but like I said, I didn't expect it to fit. It's going to need a little bit of filing. And that's how I wanted it. I want these to be a really snug fit so they go on and don't fall off. But yeah, I'm pretty happy with that. What about this brass one? So this is where the brass handle is meant to fit on these two squares here. Now this one, it's a bit tighter. I can get that to open up again with a square file, so I'm not too worried about that. But that allows you to tighten both those square shanks there. So I'm going to go back and work on these with the square file for a bit, and then I'll show you when I get them fitting. Okay, that took very little effort at all to get that to slide on there, and I'll show you what I did back at the bench shortly. But what I found out is that these square ends are not necessarily parallel across the faces, and they tend to get tapered, so they get tighter as they go on. But that means you can knock that on there and it's sort of not going to fall off. This one here is a bit tighter, and what I did with this one here is I just dressed it lightly with a file. I'll probably have to do the same with this one here. Now this is highly unconventional, but what I've done is I gripped a square file in the vise, and what you can do then is just put the square socket over the file and just rock that backwards and forwards. You'll feel when it's sitting on the flat surface of the square, and then you can just sort of work that backwards and forwards. Now I think doing it this way there's less chance that you're going to bell mouth the square. Of course, it'd be better if you had a bigger square file, but I don't have one. Let me try that. Okay, that's taken about 3 trips backwards and forwards to the vise, but that's going on there now. And that's actually as far as it can go. This parallel section on the square stops about there, and then it's got like a curved or a run out section at the bottom there. So that's really as far as that can go. Now this one is a bit tighter, which makes me think that this is probably the one that's been most worn. That does go on there. I may have to dress this one a little bit with a file. It's sort of tighter that way than it is that way. So that leads me to believe that this one is not perfectly square. But with that one there, that's fine, and you can lock it up, and it's plenty strong enough for what it needs to do. So that's it. What I'm going to do now is I'm going to sandblast these and powder coat them, and I'll show you when they're done. Happy days. Well, there's our two handles now. These are completely finished. With this aluminium handle here, this had to be drilled and tapped with an M6 thread, and I made a new steel handle in the lathe. It's a fairly close replica for the original handle, but instead of rotating its boss, it's actually locked on its thread there. And both of these were in the sandblaster, and that just prepares the surface for powder coating. And these have been powder coated in a silver vein, and they're a really nice fit, and you don't have any of that issue with the handle sort of coming loose and falling off. And just for comparison, there's the original handle, here's the replica, and you can see how loose that is there. And in fact, the square socket was way too loose to be safe, really. So let me take this over and I'll put them on the machine and show you how they fit, and we'll run the machine. I'll show you a couple more things that I've done in the last couple of days. I've set this up with the shear tool, and I've just been running the cut on this big block of steel here, and it just cuts beautifully. You get these beautiful spiral shavings, and it leaves an immaculate finish on that piece of steel. Let me show you close up. So yeah, super happy with that, but like I say, I need a lot more practice with the machine. Still just sort of taking baby cuts with it at this stage. I'll soon learn what it's capable of though. Anyway, let's have a look at the handles. So here's our feed handle, and it just slides on there nicely, and it's nice and secure and it won't fall off. I did actually dress these two square shafts a little bit just to make it slide on more easily, and yeah, I love that. It's great and it looks nice. Let me show you the other one. So there's our locking handle, and again it just slides on nicely. It's just the right length to get leverage to unlock that screw there. Now brass is not the ideal material. Obviously forged steel would be much better for this, but with the equipment that I've got, this made a very viable alternative to forged steel. Let me take you around the other side and I'll show you the new etched brass plate that I made. So this is the most recent addition. I did move the oiler a little bit further along to the left hand end of the ram, and this brass plate here, I didn't chemically etch this. I ended up doing it on the CNC milling machine, and I rotary engraved it. And at the moment, that red that you can see there is just some felt tip pen that's been rubbed into the engraving marks. At some point we'll powder coat that in red. I've actually run out of red powder coat which is why I did it that way. But yeah, that looks nice, and it doesn't have any battle scars in it, so I think that's fine. Well, that's all for today, and thank you very much for joining me in the workshop, and I hope you learned something. I hope you try those sand and epoxy cores if you're doing your own home casting. Certainly works for me. And in the next video, I want to trial a process for preventing steel surfaces in your workshop from going rusty. Now, I've already done this process, and I've been waiting to see whether the rust comes back. And I've got another product that I want to show you, which is really good for preserving steel surfaces if you want to sort of put them away for a while and not use them. And after that, I've got another metal casting project coming up, which is to replicate an old vintage toy, and it's going to be an aluminium casting, but there's a lot more in it, pattern making and also duplicating the wheels. So join me for that. That's going to be a cracker. Okay, it's Presso signing out for now. Cheers.